What does this do to glaciers? Well, this was discussed already in the 70s by Bob Thomas. It ungrounds them from the bed, because if you melt the front of the ice, the part that's grounded is going to retreat. Whether it's an ice shelf or a calving front, it's going to do the same thing. That point, the grounding line here, is going to retreat. As it retreats, all the glacier upstream is going to feel less resistance to flow. It's going to be able to flow faster because all that ice that was grounded before it in previous time is not there anymore. So the ice can flow faster. Speeds up. Whether it's an ice shelf in the Antarctic or glacier grounded below sea level in Greenland, they speed up. And if they retreat into a bed that's deeper inland, the process becomes acclimatic. You cannot stop it, because once they retreat in deeper bed, they calve faster, they thin faster. There's positive feedbacks that make the glacier retreat and not stop, even if you change the climate. What does that mean for sea level rise? At the current rate of acceleration of these ice sheets, we're going to get 50 to 1 meter sea level rise by 2100 from the ice sheets alone. Then you add the mountain glaciers and the ocean, the thermal expansion, you're going to get this number. There was a paper published just a year ago by Tad Pfeffer who looked at the possibility that all these glaciers speed up. He looked, let's see how fast they can speed up in Greenland, how fast they could speed up in the Antarctic. And he said, well, there's no way we're going to go exceed 2 meters of sea level rise by 2100. However, you assume that the glaciers were going to keep discharging in the same flux gates, and this is not really likely to happen. There's a new study, I didn't put the number here, from Stefan Ramsdorff, who is correlating global temperature with sea level. When the Earth is getting warmer, sea level is rising, and you can correlate the two, and then you can make projection of what sea level rise is going to be in the future. Whether it's melting ice or thermal expansion, doesn't matter, you have a global number. His latest result published in Nature puts a range for 2100 between about 1 meter to 2 meter sea level rise. Now, if you read the last IPCC, which was dated 2007, they predict 50 centimeter sea level rise by 2100. So what's really going to happen is going to be 2 to 3 times bigger. Why is that? Well, because there's a little asterisk in that IPCC report that says, oh, well, this number does not include the fact that ice sheets could accelerate, the glaciers could accelerate. If they do, well, that could change that number quite a bit. Yeah, it could multiply it by 2 or 3. Why are we so far behind? Well, ice sheets are not supposed to change that fast. We're not funded very well. The ocean and atmospheric community, they are data rich. Us, glaciologists, we're coming out of the woods. We're coming out of ice caves. And there's a lot of inertia in scientific programs, funding agencies, even your colleagues, into starting something new to answer some important questions, because these ice sheets are evolving fast. They're evolving faster than we are, and that's a problem. So what's next? Option 1, move to the hills and don't tell anyone. Option 2, enjoy the scientific knowledge and publish lots of papers. Option 3, we hope carbon emissions are going to be limited at some point, so things don't get so bad, because it's not going to be fun anymore. Okay, it's not going to happen so easily. So we have to develop better models with good physics. It's an effort that does not involve just glaciology. It involves the whole Earth system climate community. And we need better observations. There's some observations that we don't have to build these models that are so crucial and are so basic, you would not believe it. There's a lot of places we have no idea how thick the glaciers are. There's no data. I told you about the ocean. Do you think there's data on ocean temperatures in Greenland fjords? There's none. None whatsoever. Well, there's a little bit now that we went there last year. That's about it. And educate the public and politics about what's happening. That's the easy part. Conclusions. The ice sheets are contributing sooner and faster to sea level rise. This contribution is accelerating and is dominating the sea level rise. I'm sorry for the oceanographers, but thermal expansion from the ocean is a little trickle. And all of this is caused by glacier speed up, warmer air temperature, yeah, but I think we have a growing consensus that this is the ocean. The ocean is really driving these ice sheets. In Antarctica, it's obvious, because that's the only thing that can drive the ice sheet. In Greenland, that was not obvious, and it's really emerging out of all these studies. Sea level will rise 1 meter or more by 2100. You know, we're not saying that to scare people. It's something very realistic. But even 2 years ago, I had quotations in the press saying, oh, Dr. Rignot said he thinks that it's going to raise 3 feet. Insane. This is exciting for glaciology, but predictions remain a very serious challenge. We're data poor, we don't have a lot of money, we don't have good models. And even though ice is just ice, it interacts with everything in the climate system. It's a very complex problem. It interacts with the ocean, interacts with the atmosphere. Ice itself is a very weird medium. And a lot of the flow of the ice is controlled by what's happening at the bed. And we don't see the bed. There's been a basic difficulty of glaciology forever, is we don't see the place that really matters. So don't run to the hills. Just walk. Thank you.